Okay, YouTube, this is my second video on solving systems of nonlinear equations, and which we're going to look at the equation of a line and the equation of a circle together, forming a system here. But you'll notice we have two equations and two variables, and so we're going to put to use here, it looks like the substitution method to solve this, and kind of starting with the answers, and I'm sorry to do this, but I just want to show you that we're supporting algebraically what we see graphically here, but the solution to a system, recall, is always where two solution sets intersect, or at least graphically they're points of intersection. So it looks like algebraically we're going to come up with two solutions here, 0, -3, and 2, -1. Now let's look at how we can support this algebraically. One thing I do want to mention before going any further in this video is that this says that this is the graph of a circle, at least for certain purposes. I think that it's also very important to know the standard form of the equation of a circle centered at h and k with a radius of r. So we're going to write that this is the standard form of EQ of circle. For now, this is how we want to know this. And we would say that the center, okay, is at the point HK. And maybe if you want to make a note here, they kind of seem backwards at times, because looking at the formula, let's recall here, that H and K both have negatives in front of them. They're going to appear to be kind of their opposites of what they really are. And then we say that the radius is equal to r. And so we can see that with respect to our equation up here, we see that the right number here equals r squared. That is to say, with this circle here, we say r squared equals 4. Then the radius of this circle would be the square root of 4 is equal to 2. And with respect to h and k here, we see h and k, if we were going to say the center of this circle, where it exists at, we would say h is actually positive 2, and k, which is paired with our y value here, is at -3. And so looking at what we have graphed over here, it makes reasonable sense that we go right 2 and down 3, that this would be the center of the circle. We could say we go 2 to the right, 2 down, 2 to the left, and 2 up. We could graph this, and you could see easily that these two graphs intersect at these 2 points right here, because you would have intentionally graphed them for at least both of your graphs. And so supporting this graphically, let's go ahead and take a look at how we would do this algebraically. And so looking at this, we'd see that solving it, we can't use elimination method here because we don't have kind of like things stacked on top of one another. And we've also been asked to use substitution. So let's pick a variable to solve for here. And I'm just randomly, I'm going to choose x here because it's got a positive 1 as its leading coefficient. So if we said that this is our equation here, x minus y equals 3, then what we're going to do is we're going to add y to both sides here. And so what we come up with is this new expression here, y plus 3. Now I'm going to put a box around this. And I usually, at least when I do substitution method, it's kind of a thing that I guess I say is a modified equation. This modified equation, it's always nice because when you now later come back to solve for x, you've already got x by itself. We're going to take this modified equation, and the rule is you're going to plug the whole thing into the other equation. And so here's what we need to be uber careful of, okay? Essentially, when we plug it into this equation, x minus 2 quantity squared plus y plus 3 quantity squared equals 4, we can overuse parentheses if in doubt. I guess what I mean is this. We're plugging in for the x variable here. And so what this means is we're actually going to put a set of parentheses inside these parentheses here. And we end up with this now new equation that should all be in terms of y's. We see that this is a y plus 3 here. So we're just going to simplify, essentially simplify and solve. So with respect to simplify, let's start with what's in here. We can see that the positive 3 and the negative 2, what that's going to give us is a positive 1. We have y plus 1 squared plus now y plus 3, okay, squared equals 4. Now, what we're going to need to do is FOIL out our binomials. So FOIL binomials, okay, is what we're going to do in this step here. And so we really get y plus 1 times y plus 1 plus now y plus 3 times y plus 3, okay, is 4. And when we now square these binomials, essentially over here we'll get a y squared with our outer, we get 2 y's here. So we get a y and a y, that's 2y, and then we get plus 1. There's our first FOIL, and then our second FOIL here, we get y times y is y squared, y times 3, and another y times 3, that's 3y, and 3y gives us 6y, and then 3 times 3 is a 9, and this is equal to 4. So here comes this part where we're going to combine like terms. I see that a y squared and a y squared is a 2y squared, a 2y into 6y, that is an 8y, and then a 1 here, and a 9 here, that's a 10 there, and this equals 4. So from here, what we're going to do is essentially we are going to set it equal to 0 by subtracting 4 from both sides of this equation. I'm going to try to give myself a little bit more room here. So let's do this. Let's kind of blockade this off here, and we'll drag this up over into here. But we'd say that this would be 2y squared plus 8y. And if I were to subtract 4 from both sides, this would be plus 6 equals 0. So if we're going to solve this, let's do it by factoring. First thing I notice is that everybody has a common factor of 2. So we're going to go ahead and factor out that 2. Always look for a GCF first. And actually, because this is all set equal to 0 here, let's do this. Let's divide both sides by 2. Because anything, 0 divided by anything that's not 0, what you're going to get is 0 anyways. And so what we end up with is this right here, which factors like a trinomial does, hopefully. If not, we'll use quadratic formula. But we'd say that it seems to me that two numbers that multiply out to be a positive 3 that add up to be a positive 4 would be 3 and a 1. And so since these are our factors, we say either y plus 3 equals 0 or y plus 1 equals 0. And if that's the case, then y either equals negative 3 or y equals a negative. Okay, let's fix that, a negative 1. So negative 1, I'm going to put a box around these, and most importantly, what we want to do is we want to list our solutions right now. Chances are, if you were doing this on a normal basis, you wouldn't have Desmos and you wouldn't have this graphed, and if you didn't know how to graph, you'd have to do it algebraically. So you want to make sure you keep your things really straightened out here. We're going to say that our solutions, at least what we know is we got two different y values, and with one of them we got negative 3 and the other one we got negative 1. So what we're going to do is we're going to grab that modified equation. Remember this one up over here, we say x equals y plus 3. And what we're going to do is we're going to substitute that back into our x equals y plus 3 equation, and we're going to come up with our x values here. So for our first one here, we say x equals y plus 3, where y is equal to a negative 3. It looks like we get that 0 that we had anticipated here. So we say it's 0 if y equals negative 3. And if x equals y plus 3 and the value of y here is a negative 1, then what we end up with is 2. So x is 2 if y is negative 1. And what I want you to see is that this definitely is supported graphically by our graph here, and we've supported it algebraically. So what I want you to try here is the same situation. I'm going to give you a line and also the equation of a circle here. And I would encourage you to graph both of these to show you that they cross at the point you find algebraically, but I also want you to solve for those algebraically. Cheers.